Hey everybody, and in this video we'll talk about the topic graphing a rational function linear over linear. So previously in my constant over linear video I showed a list of the steps we take when we're graphing a rational function. If you want to go back to that and write those down, then that might be helpful for this if you haven't done that already. But let's go ahead and talk about this particular problem. So again, the first step is to find f of 0 or our y-intercept. So when I do this, I get 2 times 0 plus 2 over 0 plus 4. This ends up being 2/4 or 1/2. So I have a point at x is 0 and y is 1/2. Let's go ahead and plot that. X is 0, y is 1/2. There's my y-intercept. My second step is to find my x-intercept. So that's when y is 0. I can set it equal to this whole thing, but I'm going to multiply by x plus 4 on both sides. And I'm going to end up just getting 0 equals 2x plus 2. So I'll go ahead and solve that by subtracting 2 from both sides and then dividing. And I'll get x equals -1. So I have an x-intercept at -1 and 0. Which is here. Okay. Now, my third step is to find my vertical asymptotes. That's where the denominator equals 0, which happens when x is -4. So I have a vertical asymptote at x is -4. Like that. Now, my horizontal, that was vertical, my horizontal asymptote, well, I need to look at the degree of the top, which is 1, the degree of the bottom, which is also 1, so that means my degrees are equal. Now, in my asymptote videos, I talk about what this means, but what we do is we take 2 divided by -1 as our horizontal asymptote. So y equals 2 is our horizontal asymptote. Okay, so how do we graph that? Well, we go to y equals 2 and we mark in a horizontal asymptote. Okay, now step 5 is to see if the function crosses this horizontal or slope or slant asymptote. So this is at y equals 2, so we let y equal 2, and then we solve the equation. So this is 2 equals 2x plus 2 divided by x plus 4. Now, how do we solve that? Well, we need to multiply both sides by x plus 4. So, when we do that, we'll get 2 times x plus 4 equals 2x plus 2, because the denominator and our x plus 4 go to 1. So we end up getting 2x plus 8 equals, it really does not love my writing for this video. Equals 2x plus 2. Now we can subtract 2x from both sides. Those are both going to go to 0. And I get 8 equals 2. That isn't a true statement ever, so it does not cross. Alright, for 6, we already know that we could do some testing for symmetry, but we know that since we have an asymptote clear at this -4, we don't have another asymptote at the +4, so there's no symmetry. We also don't have, and if we flipped the asymptotes around the origin, 180 degrees, we wouldn't have asymptotes down here. So there's no symmetry. So number 7, step 7, is to plug in some points. And remember, we want to plug in points to the left and to the right of our asymptote. So if we plug in a positive 1, we will get 4/5. Then 4/5 is almost 1, so we're here. If I plug in 2, I do get 1. So at 2, we're at 1. Now, we could be done on that side, but we could also plug in -2 and get a little better idea that that goes down to all the way to -1. So my curve is gonna go up towards my asymptote and then down towards my y. So y is going to -infinity there. Then if I plug in -5, I get 8. So at -5, I'm up at 8. And you can check these values with, okay, just to plug them in and get practice. Right? When I plug in 6, I should get 5, or -6, I should get 5. And then when I plug in -7, I should get 4. So I'm going to end up going up to infinity, and then as x goes to infinity, I'm going to go down to y equals 2.